This video is on numerical integration method, specifically trapezoid rule. And so as in the illustration of trapezoid rule, I'm going to use what's called the normal distribution and SAT scores. A function like this one, f of x equal to 1 divided by the square root of 2 pi times sigma times e to the negative 1/2 x minus mu divided by sigma squared. This is called a normal probability density function, or PDF, where mu is the population mean and sigma is the population standard deviation. And so, for example, when mu is 1028 and sigma is 221, then this function right here, then the graph will look like this. And then the area between the graph and the x-axis from negative infinity to positive infinity is always going to be 1. And then for those of you who are interested in understanding why this is equal to 1, I made about 3 videos explaining why this is equal to 1. And so the links to the video, the 3 videos, are in the description section. For the year 2023, the population of SAT scores, the mean or the average is 1028 and the standard deviation is 221. Now SAT scores, they are known to follow what's called a normal distribution. And so we can model the population of SAT scores with this function right here, using sigma, using 221 for sigma, and then 1028 for mu. And then the function would look like this. So this function right here, this would be for the population of SAT scores. And then what it allows us to do is this. Let's say I want to know what percentage of SAT scores are above 1400, or what percentage of SAT scores are below 800, or what percentage are between 800 and 1100, and so on. And so in statistics, we have something called the empirical rule. And it says this, for a population that follows a normal distribution, like the SAT scores, then about 68% of the score of SAT scores are between mu minus sigma and mu plus sigma. So in this case, mu minus sigma is 807, and then mu plus sigma is 1249. And so the empirical rule says that about 68% of all SAT scores are between 807 and 1249. And so in terms of the integral, it means that the integral from 807 to 1249 is approximately 0.68. And then graphically, the area from 807 to 1249, so this area right here between the x-axis and the graph, will be 0.68. The empirical rule also says that about 95% of all SAT scores are between mu minus 2 sigma and mu plus 2 sigma. And so in this case, it'd be 1028 minus 2 times 221, and 1028 plus 2 times 221, or 586 and 1470. And so here's 586 and here's 1470, and then the area between the graph and the x-axis from here to here will be 95%, or 0.95. In terms of the integral, then the integral from 586 to 1470 will be approximately 0.95. And then the empirical rule also says that if we, from the middle right here, if we go 3 sigma to the left and then 3 sigma to the right, or the interval between mu minus 3 sigma and then mu plus 3 sigma. So right here in the middle, this is mu, and then right here, this would be mu plus 3 sigma, and right here, this would be mu minus 3 sigma. And in this case, we'll get 365, and then at 1691. So the area between the graph and the x-axis from 365 to 1691 will be about 99.7%, or 0.997. So this is what the integral would look like. It'd be the integral from 365 to 1691. And now suppose I want to know what is the what percentage of SAT scores are between 800 and 1100, meaning I want to find the area between 800 and 1100. And so we need to evaluate the integral from 800 to 1100. So we need to evaluate this integral right here. And so the problem that we're going to have is this. This function right here, this function, it has no antiderivative. And so in order to evaluate this definite integral right here, we have to use what's called numerical integration in a method like either Trapezoid's rule or Simpson's rule to find the value of this definite integral. And so let's use what's called Trapezoid's rule to find the value of this definite integral. And so here's how Trapezoid's rule works. And so here's our shaded region here. So we want to find the area of this shaded region right here. And so what we would do is fill it up with an n number of trapezoids. And so for this in here, I fill it up with 4 trapezoids. And then what we would do is find the area of each trapezoid, and then add the areas of the 4 trapezoids together. And then that will give us an approximation for this shaded region right here, which represents the percentage of SAT scores between 800 and 1100. And so instead of finding the area of each one individually, then Trapezoid's rule, we have this formula right here. And so this is the formula, and so let here n would be 4. And so we have 4 trapezoids, and then n would be 4. And then we would use this formula right here, and that will give us the 4 areas of the trapezoids. The first thing that we need to do is divide the interval from 800 to 1100 into 4 sub-intervals, since we want 4 trapezoids. So the 4 sub-intervals will have values of 800, 875, 950, 1025, and 1100. So this would be x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. And then to use this formula right here, we would need f of x sub 0, f of x sub 1, all the way up to f of x sub 4. And this is what they would look like. And so here's x sub 0 up to x sub 4, and then here are the function values. So to get these function values here, we would go to this function right here. In the place of x, we put 100, and then we'll get this. And then for this one, we would, in the place of x, we would have 875, and then we would get this value for f of x sub 1. And then we would use these values, function values right here, and then plug them into this formula right here. And then a would be 800, b would be 1100, and n is 4. And then work this out, and it'll come out to be about 0.473. And therefore, the percentage of SAT scores between 800 and 1100 is about 47.3%. So once again, when we fill the shaded region right here with 4 trapezoids, then we get an area of, we get an approximation of 0.473. And here's what we'll get if we fill it up with 8 trapezoids, then it's 0.4757. And then here's 12 trapezoids. And so the more trapezoids, the more the better the approximation we'll get. And so the percentage of SAT scores between 800 and 1100 will be about 47.65% here. And so in summary, to use what's called trapezoid's rule, the first thing we need to do is we need to divide the interval, in this case 800 to 1100, into n sub-intervals, and then find the function values for each x bar, and then plug in, and then use this formula right here to find the value of this shaded region. And that's the end of the video.